Pradnya, hello. Can you see my screen? Hello.
Yes, sir.
Okay, so today we are going to discuss on geotechnical report study. All of you know that it is very much important from foundation design point of view. Can anybody tell me what is the use of geotechnical report in general? What data we get? Any idea?
SBC, sir.
Yes. Main point is SBC, and we get other parameters also, but SBC is the one of the important parameter. So let's start today's session. See, whenever we prepare any design basis report, we generally write down the geotechnical input data which is required for the foundation design. Okay, so there is some problem, I think. Yes. So we get the data of soil bearing capacity, and where we use soil bearing capacity. For deciding the size of footing, right? Size of footing. So generally, you know that we get the size of footing by load divided by SBC. So we get the area of the footing. So that is the purpose of this. We get in the geotechnical report. Then we may get this angle of friction also, which is required for retaining wall designs. Then cohesion values. Generally, cohesion value is used by the geotechnical experts only. They give you the direct value of the SBC. Generally, it is used for the soil bearing capacity calculation. Then water table data also we get, which is required for generally in high-rise building basement design, or it may be for retaining wall design also. To calculate the water pressure, we require this water table data. Basement design, basement means raft and walls. Walls means retaining walls. Then subgrade modulus, it is used for the deflection calculations. Either we get it from the geotechnical, or we need to ask them. Then we can calculate the settlements. And in geotechnical report, we get the photos of the core samples. So they take the core underground and they check that. Then core logging equipment, then trial pits. So generally, when we don't have the data of the geotechnical report, we ask the contractor to take the trial pit. And by observation, we can decide the SBC. Actually, this is not the standard practice, but sometimes for smaller projects, we can take decisions on our own. So on observation, we can get the SBC, or we can decide the SBC through trial pits. And we also get the foundation suggestions in the geotechnical reports, and they also give you the pile foundation design also. So this is in general the content in any report. Okay. Now SBC generally calculated. See, this is as a structural engineer, we don't have the authority to calculate the SBC. In general, I say we don't calculate this. This is the role of geotechnical consultant. But the standard formula is soil bearing capacity is nothing but C and C plus Q and Q plus 0.5 gamma beta. So there are many parameters actually given here on the basis of which they calculate. So this C value, they depending on the soil properties, they decide this C value, Q value also they decide this. And finally, they give you the soil bearing capacity after these calculations, depending on all these values. Depending on all say underground properties of different soils, they get this final calculations. Okay, so all of you know that the soil bearing capacity is related with the cohesion of the soil, that is the shear capacity of the soil, and it is also bearing pressure depending on that. So these are the parameters which are used in soil bearing capacities. See, we are not going in detail regarding this because this is the role of geotechnical consultant, but we should know at least the parameters they are using. And then different C and C value and Q values are given in the IS code 6403, and through that they calculate the SBC values. Yes, now if you look at these types, you can see this kind of soil is a wet clay or muddy clay. So in that case, if you don't have any data, you can assume this data. See, many times as a structure engineer, for smaller projects, we need to take decisions if the geotechnical investigation is not done. So for your understanding, I'm just giving you these photographs so that you can decide the SBC. If you're not confident enough, then you can decide the lower values of SBC to be on the safer side. So wet clay or muddy clay, then we can say this is the value 50 kilonewton per square meter. These are the SBC values. Soft clay, but better than muddy clay, we can say, then we can go for 100 kilonewton per square meter. Black cotton soil, you can assume 100 kilonewton per square meter. Loose or dry sand 150. But we don't allow the footing on the surface of the soil. We go underground. All of you know that, let's say this is the ground level. Then we definitely put the foundation below the ground. Let's say this will be the foundation. So we ask the contractor to dig the foundation, let's say till 1 to 1.5 meters below the ground. And then we tell them to raise the footing. Once you dig the ground, we take the test pit. We can decide the strata here at this level. Let's say 1.5 meter we are going. Then if it follows, let's say this black cotton soil or this kind of soil, then you can decide, shall we take 50 kilonewton per square meter or 100 or 150, depending on the soil properties. Okay, so this is the general soil bearing criteria. Here also, now this is the moist clay or sandy clay. 150 kilonewton per square meter, medium and compact dry sand. So see, many times we get the compacted strata. You can go 200 kilonewton per square meter in that case. Then medium clay, again, if it is a, let's say, compacted enough, then you can go for 250. So generally, if the data is not available, we assume, but it should be, if it is a compacted strata, let it be sand or clay or murum also, then you can think of 200 to 300 kilonewton per square meter. For bigger projects, geotechnical investigation is done, and they will give you the SBC directly. So don't worry for bigger projects, but smaller projects, these values will help you. Compact clay 300, compact gravel 450, 300 to 450, we can say. Soft rock 600, and if the rock is quite strong, laminated, then you can think of near about 1500 kilonewton per square meter. And it is so hard, then you can go even 2000 to 3000. Okay, so this is the, we will share you this data to you. So now these are the photographs by which you can understand the strata, and these are the numbers for that. So we have say developed a table so that you can get an idea what should be the bearing capacity of the soil. Then angle of repose, all of you know this term. So I will tell you one more thing. Can anybody tell me on the retaining walls, why is the pressure of the soil? why we get the pressure on retaining wall? Anybody? If there is, why we provide retaining walls? Yes. Hello. Am I audible? Hello.
It's used to supporting the soil.
Yeah, supporting the soil means soil is creating pressure. So can anybody tell me why soil is creating a pressure? See, let's say this is a soil. I'm just imagining this soil is there, right? Soil block. So if you put the soil like this, definitely soil cannot stand like this vertically. Okay. Like slice of we can, so a cheese cube. You know that whenever you see the cheese, it can be formed in a rectangular shape or cubical shape. So this vertical edge can be possible in cheese. But if it is a soil like murum or sand, it cannot have such kind of texture. It will, whatever, if you see, this is the, let's say, portion, and this triangular portion will fall down, right? And finally, the soil will have a such kind of shape, right? Because within this line, it cannot stand. It will fall down like this, whatever you have seen here. That means whenever it tries to fall down, definitely, if you provide retaining wall over here, it will exert a pressure. So why we provide retaining wall? To retain this soil. And this soil is trying to fall down, and that's why it will apply a pressure on that. Generally, that pressure is triangular in nature. So this wedge of the soil will try to fall and will exert a pressure on this retaining wall. So that is the reason. And for that, we generally require this angle of friction data like this. So all of you know that 1 minus sine phi upon 1 plus sine phi. So we generally use this K A gamma H for lateral pressure of the, and this K is nothing but this, right? And this sine phi, so we require the sine phi values from this. Okay, angle of friction values. Then cohesion, it is used for the SBC calculations. And water table, yes, we know that if there is a basement raft, I'll show you here. If there is a basement raft, let's say there is a building, and if there is a basement, let's say double basement is there, B1, B2. Okay. And this is a ground level. And let's say we have a water table here. So if we have a water table underground, then this water will exert pressure on this retaining wall, right? So that's why water table data is very much important. So this will be your, see, there will be soil pressure like this, because soil is from here to here. So it will exert pressure on the retaining wall, and there will be additional water pressure like this. And that's why we want water table data. So, and we get that from the geotechnical reports, so that you can understand that I will take this height of the water for calculation of water pressure. Similarly, you need to calculate the uplift water pressure on the raft. And that's why also you require this data. So this H is important. They will give you, the geotechnical people will give you this data. So what is the height of the, or level of the water below the ground? This is your ground level. This is your water level. So this, let's say we have a groundwater table at 3 meter below the ground. And let's say if this is a 3 meter floor to floor height, and this is 3 meter floor to floor height. So for this portion, I will take water pressure will be gamma H. So gamma is our water density 10 kilonewton per meter cube into H is now here it is 3. So 30 kilonewton per square meter will be the lateral water pressure in design of the walls, and also for this uplift pressure also. So that's why we require the water table data. Okay. Yes, we have seen this. Now there are do you know all of this saturated unit weight, dry unit weight, and submerged unit weight of soil? Anybody knows this terms? ये क्या है? Saturated unit weight क्या है? पता ही गई. Gamma saturated. Then there is a dry unit, gamma D, and there is submerged unit weight, gamma S. Yes, पता है किसी को?
So dry means there is no moisture in the soil.
Yes, there is no moisture in the
And
soil,
there
right?
is no moisture.
Uh-huh.
And if there is moisture in the soil, then it is saturated unit weight. And if it is below the water table, then it is submerged saturated.
Right, right. Yes, yes. So what happens? Let's say there is a building. Let me draw here. So if there is a building, and let's say we have a basement here also, same problem. But in this case, I don't have any water table. Let's say water table is below, quite below this building level, foundation level, right? Then if this soil is there and let's say there is no possibility of any rain or saturation of this soil, then if you consider the soil pressure here, let's say there is it is a dry area where there is no possibility of rain in general or very less, then whenever you calculate the pressure of soil on this retaining wall, then K gamma DH. So you take the gamma D value. So generally gamma D value, I'm just giving you general idea. Gamma D value is 18 kilonewton per meter cube. Okay. Now let's say in this building, there is a rainy season is there in that area and this soil gets saturated or it is a moist soil. So in that case, I can say you need to take the saturated unit weight, which is generally roughly 20 kilonewton per meter cube. So it increases due to the addition of the water here. Addition of water means it is not under water, but moist soil, we can say. That's why the general unit weight gets increased. So it is a 20 kilonewton. So depending on the criteria, you can decide what gamma value you should take, either dry or saturated. Now, if you see here, so in this case, you can see this is a Ka gamma H, which is a soil pressure, and this is a gamma WH. So soil pressure plus water pressure. In this case, you know that there is submerged actually. This portion is submerged into this. That means water is there within the soil always. So in that case, you need to take the submerged unit weight, gamma submerged. Here what I did, gamma dry if it is a dry, or saturated if it is a saturated. See, there is no water table. Please keep in mind in this case. Here it is a water table. So I will take gamma submerged, and gamma submerged is gamma dry minus gamma water. So gamma dry is 18 and water unit weight is 10. So it will be roughly 8 kilonewton per meter cube. So whenever you calculate the retaining wall pressure or basement wall pressures, then you can take these values depending on your condition of the project or foundation, we can say. So these are the unit weights. Subgrade modulus, it is generally used for the settlement calculations actually. So it is roughly, we can say, load upon SBC. Okay. Load upon SBC. Into factor of safety. Okay. This we will see. I think have we done with the STADA Pro modeling किया था क्या हमने? जिनका नहीं हुआ, There we will discuss this. Okay, safe भी हुआ है ना आपका? Yes. Safe में लिया होगा वो K value क्या लेना है?
Yes, sir.
Right.
Yes, sir.
So that there we use that in safe or foundation design, rough foundation design. We need to give that K value as an input in the safe. There we use that subgrade modulus. Okay.
Yes.
So roughly I can say SBC into 100 will be the K value. Okay. SBC into 100 will be the K value to be given in the safe software. So generally how it comes, see permissible displacement generally in soil design, foundation design, permissible displacement value is 25 mm. So we allow 25 mm displacement. Definitely it is a uniform displacement. We don't allow any differential settlement. Uniform displacement allowed is 25 mm in foundation design. Using this displacement and factor of safety is used as a 2.5. We calculate get this value. Correct? SB 100 value. Now there are settlement, there is no settlement means the foundation will not settle. Generally it happens in the rock. If it is a rock here and your foundation is resting on the rock, so there will not be any settlement because rock is having more soil bearing capacity. So it will almost not displace. Then there is a uniform displacement. Uniform displacement का meaning क्या है? What is uniform displacement? Yes. See, due to the column loads, all loads coming from the building, it is transferred through the column on the footing. So if this footing, let's say this footing is displacing by 10 mm. That means all footings are displaced by 10 mm only. Let's say all footings. Then in that case, we can say that there is a uniform settlement of the foundation. And uniform settlement is acceptable actually within the limit, which is 25 mm. So there is no problem if there is a uniform displacement. But there is a possibility that you are not designing the foundation properly. Okay. Or if the strata is weak and the design of the foundation is not done properly, then there is a possibility that this foundation is displaced by, let's say, 30 mm, say example, and this is displaced by 10 mm only. Let's say this is a 5 mm. So you can see that there is a relative displacement, which is a differential settlement. And in that case, there is a possibility that the bending moments in the beams and columns will be very high. So generally, if you have seen the buildings have collapsed, many times you see that building collapse due to the gravity loads. See, in earthquake, building is collapsing is okay, there is no issue as far as, because you don't know what kind of intensity of the earthquake will be there. And if you have not designed the building for earthquake, then it will collapse. But you might have seen some buildings have collapsed due to gravity loads also. पता है क्या किसी को gravity load से भी collapse हुआ है once the building becomes old or what? Anybody knows this? कभी देखा है क्या ऐसे building collapse हुआ हुआ? Without earthquake. Falls down. The main reason of the collapse of this building is the differential settlement. So this parameter is very, very much important. So you must do the foundation design properly. Especially this differential settlement happens in soft strata. Then it may happen in infilled soils. Do you know what is meant by infilled soil? पता है कि इसका मीनिंग क्या है? What does it mean by infilled soils? See, many times what we do during the construction, let's say this is your ground profile. Huh? Okay. Let's say this is your ground profile. And due to the architectural requirements or overall ground conditions, it is needed. We will have a flat ground like this, and what we will do, we will fill the soil here. So actually natural ground level is this, like this, and we are filling the soil here. The filling may be 1 meter, 2 meter, 3 meter, or we don't know. Let's say 3 meter soil is filled here. And then we provide foundations. And this foundation is resting on the infield soil. Let me assume this as a 5 meters, for example. And this is a foundation, and we are resting here on the infield soil. So there is a possibility that whenever you are filling the soil in this area, valley region, the compaction is not done properly. Okay. And if the compaction is not done properly, then there may be air voids here like this. And due to this load and due to this air voids, the foundation gets settled. And there is a possibility of differential settlement and finally the collapse of the building. So you must be very much, you should take the care in this kind of foundation design. So in this case, generally, if the strata is quite below, we generally give the pile suggestions to go for the piles instead of isolated footings. Or if you are doing the isolated footing, you must make sure that it is compacted properly. On the site, the contractor has taken care of the compactions. See, generally such kind of filling is done like in layers. So generally the layer is 300 mm or 1 feet. Then there is second layer, then compaction, then third layer compaction, fourth layer compaction, fifth layer compaction, and the Proctor density is checked actually here during the compaction, which should be 95%. Okay. And then you can raise such kind of foundations, but for smaller structures only, not high-rise buildings. And in this case, generally we assume the SBC compacted soil. Still we assume it as 100 to 150 kilonewton per square meter. So these are quite important aspects during practical design of any structure. If it is a 1 story or 2 story, it is fine. But if it is a 5 story, 6 story, or then the footing load is very high, then it is better to go for the piles. So that is the important, and that will have a uniform foundation settlement in this case. So that's why you must know this kind of settlement in foundation design. Yes, I think you have learned that in the college that such kind of core samples are taken during geotechnical investigation. They are numbered, and at every level, what is the strata, they check it. And finally, they prepare the core logs graph, we can say. So these are the equipment generally they use for the, say, geotechnical investigation, similar to, we can say, pile foundation. Now we will go in only important investigation methods. One is the trial pit method. So when there is, we don't do the general, say, geotechnical investigation by using borings. So this is the boring actually, or core logging, we can say. These are the core logging where we go underground 10 meters, 20 meters also. It's quite below. But if the strata is good and the structure is very small, then you can go for trial pits also. So what we do generally, if this is such kind of trial pit we take, let's say this is your ground, then we can take the trial pit of, let's say, 1 meter by 1 meter by 1 meter, let's say. This not 1 meter here, it depends, depth depends on the hard strata. Into H. One meter width, 1 meter length, and H. H means this. This depends till the hard strata we dig this. So this level is hard strata, where we are thinking of resting the foundation. And then we let's say this is the hard strata, and then we can raise the footing on the hard strata level, right? After PCC, we generally provide PCC first and then concrete footing. So this is the general, say, simple method of doing the investigation for smaller projects. For bigger projects, we generally go for the boring, and we do that. Then in geotechnical reports, we also get the foundation suggestions. They may ask you to do isolated footings or combined footings or strap footings like this, or pile foundations or rough foundations. So these are the way the foundation is done. So rocky soil, if it is a hard strata, then you can go for combined foundations, isolated foundations, isolated also. Rough foundation, depending on if it is a high-rise building and basement, then raft is compulsory, even though it is a hard strata or step foundation. Then in gravel or sand, it is a medium, we can say medium strata. You can have isolated, combined, raft, strap. In clay, we can go for raft and pile also. So if it is hard, then you can think of only raft, no need of pile foundation here. And if it is soft clay, black cotton soils, then pile foundation and raft foundation, either individual or combined also. So we can hybrid system also. Hybrid means we are providing raft also like this, mat or raft, and we are also providing the pile below that. So this is a hybrid system, raft plus piles. For very soft soils. Pile foundation may have single pile, double pile, 3 piles, 4 piles, or group of piles. Now, geotechnical report will give you the capacity of single pile. Okay. So let's say the diameter of the pile is 500 mm. And let's say they are giving the capacity, say, for example, for single pile, let's say they are giving you 500 kilonewton is the working capacity of the pile. And let's say the load on the column is 2000 kilonewton, for example. That means how many piles are required here for this column? Kitne lagenge? 200,000 kilonewton working, I am saying. See, working is important word, because generally we design the columns for ultimate loads, PU. But whenever we design piles, we design it for working loads. So if your PU is, let's say 3000 kilonewton ultimate load, then what will be the working load? 3000 divided by 1.5. So it will be 2000 kilonewton. And then you compare this with this. Now, how many piles will we will require for this? Kitne lagenge? 4. So 4 number of piles will be required. So we are taking the decision of this on the basis of this data given by the geotechnical reports. So you need to check the actual load of the column and then check the capacity of the piles and decide 1 number, 2 number, 3 numbers. When to use pile foundation? Yes, underground water is there and strata is not good below the ground. Sometimes we compare the pile foundation with the raft foundation also. And if we find the cost is more for the other foundations, then we can go for pile foundations. See, it is not necessary that pile foundation will be always costlier. Sometimes it is cheap also. When soil at shallow depth is not is compressible, so infield soils we can say. And near the rivers, riverbed, you know that we have a marshy soil. So in that case also we can go for pile foundations. Then soil excavation is not possible to desired level. This is also maybe possible. Or if there is a, let's say we have this is a soil level and till 6 meters lay, for example, we don't find any hard strata. Then to dig this soil till 6 meter may not be feasible. It is very costly also, or have a safety issues also. So in that case, if you know that the hard strata is quite below the ground, then we can go for the pile foundations. So these are the areas where we can think of pile foundations. Okay. And we can even think of pile foundation if there is an uplift issue. Sometimes for water tanks, generally, if the water tank are there and water tank level, let me show here some. If see, generally water tank levels are governed by the location of or levels of the water tanks. So we cannot decide the level of the structure. It is decided by the architects or functional requirements. And let's say this is a water tank level and the bottom level is also fixed. Say it is an on-ground water tank, which is, it may be in sewage treatment plant or water treatment plants. It is not necessary that we can raise this raft below the ground at hard startup because the level is decided by the architects or functional requirements. That means this is our water tank and level is also fixed. And let's say we have a soft start over here. So definitely, as it is a soft, we cannot raise this structure on this, and then we will provide piles in this case. So even for smaller depths also, sometimes we may go for piles. Because I cannot raise this raft at this level, even though I know that there is a hard start over here, still I cannot rest. And there is a possibility that if this depth is quite small, let's say it is 2 meters below the ground, then instead of piles, you can suggest the columns here. Okay, and then I will provide footing over here. So isolated footings are here. And these are the columns, not piles. And then I will provide beam here. And on the beam, I will provide the slab, raft slab. So these are the ways we can decide the location of foundation, types of foundations in structures. See, types of pile foundation will be decided by the geotechnical consultants. Yeah, for just understanding the capacity of pile is how we decide the capacity of soil piles. So there are two parameters by the capacity of the pile is decided. One is the skin friction. So as there is soil over here, this soil will have a frictional resistance here around the pile, right? So that is, we call it as a skin friction. So this is the resistance we get through the skin friction also. And then when we raise the pile, let's say this is a hard rock or hard rock, let's say. When it rests on the hard rock, then this area of the pile, let's say this is your circular pile. Then the SBC of this rock into this area will be the end bearing capacity. So we call this pile as a end bearing piles. And if you are taking the resistance of skin friction only, then you can say it is a friction pile. And if you are taking both friction plus end bearing, then we can say it is a, let's say, hybrid system. You are taking skin friction also, and you are taking end bearing capacity also. So in skin friction calculation, we require C, cohesion values. And in end bearing, we are using that NQ values and all that in formula, whatever we have seen. Okay. Now in this case also, whenever we provide any piles, this area is soft area, actually soft soil area. So now there is a question where you will say decide the fixity. So if you are doing the building design, can anybody tell me? Samjho, yeah. Let's say these are the columns in the building. And you know that the strata is soft strata. So we are deciding the piles. So we will provide piles here like this. Okay. And pile may go quite below till the hard strata. We don't know where is the hard strata. Hard strata may be 10 meters below the ground. And in StatPro software, we know that whenever we model the building, what we do, we model the building like this. And let's say this is your plinth level. The below the plinth, I provide the fixed support like this. And let's say plinth is a ground level, for example, for time being. And let's say we are having hard strata 2 meters below the ground. So I will provide these fixed supports, right? I'm providing the fixed support here 2 meters below the ground. Now, in this case, the pile is almost 10 meters below. So कहाँ fixed support लेंगे? यहाँ, ये तो 10 meters below है. Can I take like this? In modeling, ये 2 meters, instead of 2 meters, shall I take 10 meters here? So will it be fixed support condition here at this point? Anybody from you? कहाँ लेना है फिर ये? Where should I give this fixed support? 10 meters below?
At pile cap level?
Pile cap level, we don't know. Pile cap level maybe here. समझो यहाँ है मेरा. Say 1 meter. Let's assume that I am having a pile cap is 1 meter below the ground. Okay. So shall I take at 1 meter?
I guess yes.
Okay. Generally, see, I will tell you. Let's say you know that underground, whenever you drive the pile below the ground, let's say you are driving this pile below the ground, due to the machinery and movement over here, this soil gets displaced. Okay, so there is a removal of soil. We remove the soil here also, because for what? For this pile cap construction, we are removing this soil, and due to the say man movement, machinery movement, this soil gets displaced. And I can say till this level, the soil is soft and displaced. Okay. So it is not a compacted soil. Soft and displaced means not compacted, let's say not compacted properly because it got displaced. So whenever you drive the pile, see, we are driving the pile from here itself, from this ground, but there due to that pile cap construction, we need to remove this soil also sometimes till this pile cap level. So below the pile cap, I would say you assume, let's say your this pile cap level is 2 meters, let's say. So I would suggest take 2 meters, 1 to 2 meters here till this. That means I can say this is a compacted zone now. So whatever red line I am drawing, this is a compacted soil. Okay. And this is a soil, soft and displaced soil or uncompacted soil due to construction activities and requirement of pile foundation, pile cap at certain level, 2 meters, 1 meter, whatever. So I would say take below the pile cap 2 meters or 1 meter. And this within the compacted zone, this is the level of support you should take for modeling. Okay, getting this? Generally, I would say go for 3 meters to 4 meters, which will be a conservative approach and will be a good because you may not know what is happening on site. So 3 to 4 meters we generally take. 3 to 4 meters means height of the floor, we can say, for example. So this way we can decide. So you are here, you can say this is a soft soil, hard soil. So this will be my location of fixity in modeling, right? Yeah, there are different types of piles, timber piles, concrete piles, steel piles like this. Geotechnical investigation, people will give this such kind of suggestions. Generally for bigger projects, steel pile, concrete piles can be used, and depending on the cost of the pile foundation, we can decide which should be chosen for that. So generally we take the parameter like cost while designing the foundation. We also take constructability, whether it is feasible for that project. So these kind of parameters we use while deciding the pile foundations. Generally, we have an interaction with the geotechnical people, clients, and finally we take a final conclusion, or we decide the golden mean between this. And there are different IS codes available for pile design, IS 2911, and there are different parts. Okay, so these codes are used for pile design. Now I will show you one geotechnical report. I think in high-rise building, you might have seen this. So this kind of geotechnical report we get in for any project, and they're giving certain information here. You can go through this. I will share with you. Finally, in the beginning, they give you summary in general. That site is suitable for proposed construction of residential building. And open foundation is recommended for the structure. Open foundation means isolated footings. The safe bearing capacity of 35 tons per meter square. So generally they gave the SBC in ton per meter square. So if you multiply by 10, then it will be 350 kilonewton per meter square SBC. And they are giving isolated footing at a depth of 4.5 meter below the ground. Okay. So the level of hard strata is 4.5 below the ground. So for your project, we can say 4.5 meter is the hard strata level of this SBC. So at different levels, the SBC may be different. They are suggesting this. As a structural engineer, you can have some other suggestions also, but you need to verify the geotechnical report and core log reports. Okay, so we will see what to do. The estimated settlement of the foundation is expected within allowable limit, 12 mm in rock and 25 mm in soil. So this I have discussed with you. So they are giving this data. Groundwater was not encountered in the boreholes. So let's say for this project, there is no water table. Groundwater, okay. Now here in general, this is the classification of soil below the ground. Layer 1, 2, 3, 4, 5. And see range 0 to 3 meters. I will do one thing. Layer 1, layer 2, 3. See, what is the meaning of this? So just try to understand. Let's say this is your natural ground level, and they have done the drilling here. Okay, so bore log, core log, we can say, not bore log. Okay, so this is your core log. So we are drilling this below the ground, and in that we are getting different, we can say, this is your first layer, then let's say second layer, third layer, fourth. So layer 1, 2, 3, 4, 5. Okay, so first layer, what they are saying, see, we are starting from the ground and we are going down. So first layer will be filling material. So as I told you, whatever soil is here within this line. So this is filling material here. And what is the level 0 to 3 meters. So this is your 0 level, and 0 to 3 meter is filling material, soft soil we can say. Then silty clay with sand, 0 to 4.5. Actually, this is the ordinator, so it will be 1.5 here. It is a silty clay, a silty sand, 0 to 5 meters, so it is a 0.5 meters, let's say. And then actually they should give this 0 to 10. Yeah, kuch to gadbad hai kya? Then we have, let's say, amygdala basalt. See, it is not necessary that geotechnical people are also doing correct everything, not necessary. Reddish AB. Let me assume now this. And then fractured compact basalt. Okay. So this way we can identify. So this is the general, we can say, strata, and they are saying, please provide your foundation at 4.5 meter level. So layer 2, within layer 2, I will have my foundation as per their suggestions. Okay. Yahan kahan to hai. And then say, let me draw here somewhere. This is my 4.5 meter level, and then I will provide footing like this. Okay. Isolated footings. And the SBC at this level is 35 ton per meter square. Sometimes you may think it is their suggestion, but if you want to provide footing below this level, let's say instead of 4.5, I want to go till 5 level. Samjho. I want to go in the third layer, let's say. So my footing will be something like this. Okay. At 5 meter level. So this is 4.5. I can ask the geotechnical consultant, please give me the SBC at 5 meter level also. Okay. If they are not giving. And let's say you are having SBC at 5 meter level, instead of 350, I am having, let's say, 50 ton per meter square. So I am having more SBC here at this level, and I can design the foundation. So sometimes this foundation cost will be less than this. So you can try different foundations. As we are using softwares like RCDC, it is very easy to do the foundation design within few minutes actually. So you can decide, think of SBC first time 35, then you can take SBC 50 in the second time and say check the cost of the project, and you can decide whether to go at this level or to go at this level. 4.5 is safe, there is no problem. But if you go for 5, it may be possible that we are having cost effective foundation design. So such kind of decisions you can take depending on the SBC reports. So this is the general summary they are giving to you. And the other data is as for their geotechnical investigation actually. So you should read this kind of data. Okay, so this is their, we can say, objective of geotechnical investigation to calculate this SBC and to decide the foundation suggestions. So there may be number of boreholes actually. In this project, it is 11 numbers and depth is 10 meters. So they are drilling till 10 meters and then they are giving you the information. So this is the general background of the project for that purpose. Then field investigation. So see, there are almost 11 boreholes taken and depth of borehole is 10 meter almost. Okay. And here, this is the core logs, borehole data, we can say. So first layer filling material thickness is 1.5. Here they are giving the thickness, not ordinates. Okay. So you can see here and you can read all the core logs or boreholes, 11 numbers. And finally, see, they give you the summary of it, but still as a matter of curiosity, you can think of this. Okay. See, rock recovery and all this, we don't see this much. And the properties of soils. So this is totally their area, specialized area. But as a structural engineer, we should know at least our part. Open foundation. Here they are saying open foundation suggestion is given and foundation should not fail in shear. इसका मतलब क्या है पता है? Foundation should not fail in shear. If you don't raise the foundation on a hard strata, then there is a possibility that it will fail. कैसे fail होगा पता है क्या नहीं? कुछ judgment है क्या? मुझे foundation है. If now it is a hard strata, but if it is a soil, soft soil, then this soil may this we can say shear failure. Okay, and then it will settle down either uniform or differentially also. So there is a failure plane within the soil, and this failure we call it as a shear failure. And when this shear failure will happen, if this strata below this foundation is soft, then there is a possibility that it will fail by shear. That is shear failure. Now see here, SBC for borehole number 1, 35. Okay. For number 2, and the depth is also given. 4.5, it is 35. 4 for borehole, it is 45. So there is a different SBC values here, given here. Now tell me, if you are a structural engineer, what SBC you will take in design, at what depth? क्या करेंगे आप बताओ? Yes. We are having SBC 35, 45, 85 also at some boreholes. क्या लेना चाहिए? Hello?
40, sir.
Okay, it depends on you. It depends how many number of boreholes are there, and if there is a majority, 40 is the majority here, and depth is 4.5, or will you take 3 meters? As a
So we
structure,
take in between like 4 meter.
yeah, you can say in that way also. As a structural engineer, it is always better to have a conservative approach or safer approach. Generally, I say, because see, holes are samples actually. So whenever they see the area of the, let's say this is the area of plot, and generally it is having a bigger size actually in acres or something like that for bigger projects. The samples are taken like this, so they are quite well spaced, and sample is sample. It doesn't mean that it is giving you the, but as we take the samples, for sometimes the geotechnical people are not taking enough samples as per the area requirement, let's say. Because client is many times thinking of cost of the geotechnical investigation, and they may not pay the geotechnical engineer. And then what happens? Geotechnical people will take only, instead of 11 bore logs, let's say, he will take only 3 or only 4 to save the cost of the investigation. In that case, what happens? You may not get the overall realistic picture, or in that case, what can you do? It is better to go for the conservative approach. And as a structural engineer, I will be happy with 35 and 4.5 meters. So I'm going quite depth below also. And I'm also taking the lower value of this SBC. Okay. As you are giving the suggestion, I will go for 40 tons per meter square and 4 meters, which is a, we can say, value engineering thinking, so that you want to save the cost. You don't want to say apply these values to all the area. That can be possible, fine, but it depends on the experience. And once you go for the site visits and once the excavation is done. So this data we are getting before the excavation of the foundation, excavation for the foundations. So if you go and see the excavated soil, if it is an open foundation, whole soil is removed. And then if you feel that 4 meter, you are getting that strata what they are giving in almost all the area, then I would say your suggestion is also fine. And if you are a new beginner and you're not sure, then I will say go for 35 and 4.5. So this way we can take decisions. If the number of samples are less, then go for the conservative approach only. If the number of samples are more, depending on the area, then you can think of that 40 and 4 something. All data is related with their investigation. Who has done investigation, how they have done, what technical parameters they have taken. Now this is the borehole log sheet actually, whatever I have drawn here. This one. This is the graph below the ground. 0 is the ground level. And then as you go below the ground, the filling material, this is the ordinate minus 1.5, minus 3 is the silty clay, minus 4.5 is the silty sand. Then this is weather basalt, compact basalt like this. So all bore log sheets are there for all bores, 11 numbers. Okay. Yes. So this is, we can say, overall geotechnical investigation and reports, site photos. This you might have done this in geological investigation, I think, in college. किया था क्या किसने geological investigation? Geological and geotechnical. Can anybody tell me what is geological and geotechnical? क्या फर्क है इसमें? किसी को पता है क्या?
So geological means पूरा लैंड मास का जो उसकी जोग्राफिकल डिटेल्स हैं, जैसे फॉल्ट या फिर उसमें किस तरह के उसका अरेंजमेंट है स्टोन्स का या फिर जो वहां का लैंडस्केप है, जबकि जियोटेक्निकल्स आर रिलेटेड मोर रिलेटेड टू द प्रॉपर्टीज ऑफ सॉइल.
Yeah, so geotechnical is more related with the soil and geology is more related with the rock or hard, and it is quite below the ground. So if geotechnical investigation is done, let's say 10 meter below the ground, for example, the geological is done maybe 100 meters, 50 meters also. It's quite deep. So we are interested in quite going below the ground. So it is for major projects, generally tunnels. You know that we are drilling the tunnels, and then there is a hill, quite big hill actually. It may be 50 meters high, 100-meter high. So we are drilling from the top to understand whether there is a hard rock, so that we can drill that tunnels. And during the tunneling, we can decide to go for lining, concrete lining or not. Some tunnels are there without concrete lining also. You might have seen this. When there is a quite hard strata like compact basalt, such kind of hard rock, then we can directly drill the tunnel and without any concreting within that. Okay, so this is the procedure is almost same. The only depth is quite high for geological investigation, and for soil investigation, depth is less. So this is the, in general, we can say geotechnical investigation. So there are many geotechnical reports. I will show you one or two. This is for some other project. Now here, I think in that report, the geotechnical consultant has suggested open foundation or isolated foundations. In this report, see, this more information is given regarding their investigation. Now here you can see strata 1 is soil overburden, strata 2 is fully weathered and fully fractured, maybe rock. Then at the end, it is a fractured basalt. Actually, it is in Maharashtra. You may be seeing this basalt is very common actually below the ground, which is very hard. Foundation analysis and recommendation, open foundation. So they are suggesting open foundation also, and they are suggesting pile also. So they can suggest both options. For pile, 7 meters below the ground. Okay. They are suggesting this. Do you know what is socketing? Socketing का मतलब पता है क्या pile के लिए करते हैं? Okay, let me first discuss this. So they are suggesting 3 types of piles. If you are using 500 diameter pile, then do the socketing 2D, and the socketing depth is 7 meters, and capacity of this pile is axial load capacity is 61 tons. That means 610 kilonewton, and uplift capacity is 1.23 tons. See, there is a uplift possibility also. If there is a let's say basement or water tanks, and if there is a water table below the ground, then there is a possibility of uplift of the raft. So in that case, the pile should not come out of the ground, right? So in that case, we are socketing this within the rock, and that capacity is given here, uplift capacity. So there is a possibility sometimes negative pressure. In that case, you should check this capacity also after the analysis. If you are using 600 diameter, then it is 2D socketing, and the level of socketing is 7 meters, and axial load capacity is more for this 600 diameter because the diameter is more, area is more. So what is 2D? Let me discuss with you. 7 meter to 8 meters. Let's say for समझो यही pile है समझो. So 10 meter है depth of the pile. Now actually in that case we are having, let's say this is your ground level, and we are providing one pile. Let's say this is the level of pile cap. And this is your pile. And above that there will be column. Okay. So what they are saying, this is your rock level. Rock. This is rock, this is soil. And this depth is 7 meters below the ground. Okay, so that means we can say there are different layers actually, layer 1, 2, 3, 4. So this rock may be in some layer 4th or 5th. When we get the rock, then they are saying drill this in the hard rock. So you are drilling this pile within the hard rock. So there will be hole here. And this depth is 2D. So drilling in the rock, we call it as a socketing. And 2D means 2 into diameter of the pile. So what will be this? 2 into 500 mm. So it will be 1 meters. So 7 to 8 meters, they are saying your socketing. Okay, this is your 7 and this is total 8. 7 to 8 means 1 meter will be the socketing in the rock. So that is the meaning of it. Okay. So as per your design requirement, you can think of any diameter. Either you can choose 3 diameters, or you can have 1 diameter and then increase the number of piles. Depends on you. So if you are going for isolated foundation, no, this is not isolated. This is a rock capacity actually they are giving. So we are not bothered about the rock capacity in pile foundation. This is the main table for us. Axial capacity, socket depth, how much socketing, and uplift capacity. That's it. So this is your summary, and then they will give you the bore logs, this layers, and all graphs. Okay. So this is one type of geotechnical report with even they are giving the calculations also. Axial load carrying capacity of piles in rock. They are using all the properties of the soil and rock to calculate the capacity. Okay. This is the site core samples. They use test that in the UTM. Then okay, all other there piles, same reports are there actually. See, different geotechnical experts are having different formats of the reports. Okay. They are giving two suggestions, open foundation and pile foundations. Okay. See this. This is our important table. Socketing, diameter, and capacity. Okay. Even capacity is different for different socketing depths. 1D, then 50, 2D, 65. So you know that rock is having more capacity. That's why the more you socket, the more will be the capacity. Generally, 2D is the general recommendations. Okay, so I hope all of you got this. So any other questions, please?
Sir, how to decide number of boreholes and depth of exploration?
We don't decide actually. It is a geotechnical part actually. So we don't decide that. Yeah, we
Does
don't
it
decide
depend
that.
on height of building or?
Mainly area of the building, we can say footprint of the building, because our foundation is within the footprint. So within that zone, you should have that first of all. So it should not happen that your bore log is hole is somewhere and your building is somewhere. Sometimes it may happen, not necessary. We have seen such kind of mistakes on site or in investigation also. And as a structural engineer, you can give suggestion to him. Yes. So let's say your building is here, for example, somewhere here. And here the structures are there, but they are not having more loads. Then in that case, I would suggest if the 11 boreholes are say decided by them, see this happens within the communication by the client, architects, structural engineers and geotechnical engineers. If we are in the communication, then we can tell them that have more bore logs here, because this is the more footing area, we can say building area. And if there are smaller structures of which the load is, we can say less, single story structure, small water tanks, or rough foundations or generator foundation, depends what kind of structure is there, then it is better to have more holes here. Let's say they have decided 11 here. Then you can tell them how to distribute this. That you can think as a suggestion. Total numbers, total number generally decided by the geotechnical engineers and clients actually. See, many times client dominates them. For bigger projects, definitely they will follow the highest codes. There are some codes available for this investigation. Okay.
That only I wanted.
Yeah, there are some codes available, I think. Yeah, sampling. Depending on the footprint area, we can say. And the weightage, here the numbers will be more because of the building area. Here it may be less. Okay.
Yeah.
Any other questions?
Sir, if footings are resting on hard rock,
Mhm.
black basalt or compact basalt, how much capacity can we take without doing any exploration?
Without any exploration. Okay. Yeah, this is
Hard rock, unjointed. This
unjointed. See, I will tell you unjointed compact basalt. I have even taken the capacity this much also for compacted unjointed basalt.
Okay, 250 ton.
Yes, 250 tons also we have taken. See, many times structural engineers are afraid of taking such kind of heavy SBCs.
Yeah.
Getting, because they are used to handle till 500 only. I have seen this. It may happen
50.
when the confidence is less, the SBC is less taken for the design.
Yes, sir. Yes, sir. Yes.
It depends on the
I have not
confidence of the
taken
structure.
more.
It happens.
Not more than 50. Yeah.
Yeah. But whenever you take such kind of decisions, you should go for the investigation, go there on the site before the foundation design. Make sure that it is really that compact basalt, and then you take this. See, the data, whenever we don't have enough data and realistic data or actually investigation is not done, then we go for the lesser values. And if there is an investigation done, quite bore logs are taken on site, enough numbers, and all bore logs are giving that SBC in the calculation at that level, then definitely this value is okay to take. If you take this SBC value, you will see that you are not getting any size of the footing almost. So it is just minimum size. See,
when I saw one report in that while taking out factor of safety, one factor is there some, and the person who did the exploration, he had written that you can assume your factor. Some
Yeah,
0.125, there was some factor, but I was not able to. He has taken the lowest one.
Yeah, he has taken the low. See what happens. Nobody is see, as this data, whatever we are getting. First of all, we are getting from the sample bore logs, right? That means it is a sample. Then once we take the sample, not necessary that in all the area, this will have the same SBC at all the area. Depends on the area. If we have more area, then and if the samples are less, then this value, I will not go for this. Then I may think of having 2000 something or 1800, whatever. Depends. If we are having enough samples for that area, then definitely this value is okay to take. Because in this value also, the soil investigation people are giving the factor of safety. Generally for soil, we are taking 2.5. So this is already there inbuilt in this calculation. And still, people are afraid to take so much of higher value. So it is very, we can say subjective, but depending on your experience and we can say conviction about the investigation, overall strata, your involvement in that investigation, and the calculation reports, number of samples. In that case, you can definitely go for this because this 2.5 factor of safety is already there.
Yeah.
Still investigate. Why soil investigation people are saying that? Because they are also having say low confidence. In that case, they will also go for lesser factors. Say more factor of safety rather. तो ये बहुत ही थोड़ा subjective है pattern. वैसे है कि structural engineer एक confident नहीं है समझो. There are two structural engineers, 1 and 2. जो confident, let's say ये low confidence वाला है, तो इसके बीम के डिजाइन में 320 आएंगे बार्स. और इसका confidence and calculation are correct, analysis is correct, design is correct, experience is also good, and he is having good conviction and intuitional means through experience he can even वो बोलेगा 316 is मेरा steel आ रहा है for the same moment, for the same span, for the same condition, everything. So this you will see low confidence, more steel, more sizes, safer approach, more मतलब low confidence के लिए, more के लिए optimum मतलब जितना होना चाहिए logically. This difference
Sir.
you will see in different many consultants. Yes, बोलिए.
Sir, one more question. In one case, I have done all the column footing design individually. Column were far away, around 6 meters far, and footing size was coming around. It was only G+5 structure and 2 by 2.5 as such size was there, and there was no water table. It was not there. So in that case, raft design we can do individually, no?
Yeah,
Because there was no load from below soil.
No. Can you again repeat your question?
Can I speak in Hindi?
You can speak anything. Yeah, बोल
Hindi or
सकते हैं.
Marathi?
Anything. हाँ,
Sir,
बोलिए.
सर एकदा मी एका बिल्डिंगचं डिझाइन केलं होतं राफ्ट फाउंडेशन साठी. I have designed all the foundation of columns individually. I am not consider any raft. And
Okay,
later
isolated
on,
footing.
while doing the raft design, means I have taken beam from column to column. So my slab area was around 6 meter by 6 meter. So if there is no load from below,
Strata was hard strata?
is not there. Water table is not there. And my backfilling was also there, quite a lot, around 1.5. So what will be the load for which I will design?
No.
That raft.
So I'm just asking you. So you have designed it first isolated like this. असं केलं होतं?
Isolated, individual footing. Yeah.
Individual केलं असं. Okay.
Without considering it as a basement.
हे खाली बेसमेंट नाहीये ना?
नाही असं मी गृहीत पकडलं की बेसमेंट नाहीये आणि इंडिव्हिज्युअल फुटिंग डिझाईन केले सेपरेट.
ओके, आता ही हाईट काय असेल?
फक्त मला राफ्ट डिझाईन जो करायचा होता तो फुटिंग बॉटम आणि राफ्ट बॉटम एकच होता माझा.
हा नाही, आता मला विचारायचंय अजून हे किती हाईट असेल बिलो ग्राउंड? हार्ड स्टार्ट असेल बरोबर?
3.5.
ओके, हा 3.5. हा हार्ड आहे म्हणजे रॉक आहे का? एसबीसी काय असेल?
हो, रॉक.
एसबीसी 600 घेऊ. 600 अजूम करतो मी.
60 टन.
ओके, आता व्हाय यू आर गोइंग फॉर राफ्ट? आयसोलेटेड फुटिंगचा साईज बेसमेंट आहे का?
हा, बेसमेंट आहे. ओनली फॉर वॉटर प्रूफिंग टाइप आहे. एक बॉक्स झाला पाहिजे तयार, जेणेकरून आतमध्ये पाणी नाही.
येस, मग इफ इट इज अ बेसमेंट देन यू मस्ट गो फॉर because there will be retaining wall na like this.
Retaining wall पण आहे.
अशी retaining wall येणार ना. And then we will have a raft like this.
Yeah.
Okay, this is a retaining wall and this is a raft. And then okay, now next question. आता ह्याच्यावरती रेस्ट करायचे.
Yes.
करता येऊ शकतं. ही थिकनेस फक्त आता कसं आहे या केस मध्ये
200 thickness.
200 ला शिअर चेक करायला लागेल. शिअर चेक फेल होत असेल तर हे नाही चालणार. Then what we do if the shear check is failing in calculation, then we can thicken here within this zone. हा राफ्ट एवढ्या झोन मध्ये थिक करायचा.
Can we take this footing projection below the raft?
like this you can go.
Take.
Yes, like this you can go. असं असेल ते.
Because काय होतं सर की आता सपोज आपण हा राफ्ट सेक्शन बॉटमला घेतला की पुन्हा त्यांना बॅकफिलिंग करायला लागतं.
हा, ते आलंच.
मग आता तुम्ही जे काढलंय त्याच्यामध्ये बॅकफिलिंग करण्याची गरज नाही, कारण माझ्याकडे खालनं येणारं प्रेशर पाण्याचं काहीच नाही.
पाण्याचं नाहीये, पण मी सांगतो कसं करायचं. हा जो झोन आहे ना, हा जर सॉफ्ट सॉइल असेल ना इथे, तर इथे हे सेटल होऊ शकतं ना. आता इथं लोड असणार ना, समजा बेसमेंट म्हणजे कार पार्किंग किंवा काहीतरी असेल, हा राफ्ट आहे ना सेटल नाही होणार रादर, कारण ह्याच्यामध्ये स्टील टाकतोच आपण. सो सस्पेंड होईल हा स्लॅब. अँड सस्पेंडेड स्लॅब म्हणल्यानंतर हा असाच डिस्प्लेस व्हायची शक्यता आहे. So if the steel is not sufficient, raft मध्ये for suspended slab म्हणून. सस्पेंडेड स्लॅब म्हणून जर सफिशियंट नसेल तर हा डिस्प्लेस हे होईल, सेटल होईल तो.
बरोबर.
There may be cracking here somewhere if it is not sufficient for
top.
taking the load, suspended load. In that case,
Okay.
आम्ही कसं करतो की इथे आहे ना, हे
डबल
परत
जाली.
हे नाही, हे फिल करायचं, डबल जाळी तर टाकायचीच आणि हे कॉम्पॅक्शन करायचं ना प्रॉपर. आणि इफ यू फील
Okay.
दॅट द कॉम्पॅक्शन इज नॉट डन करेक्टली, देन यू गो फॉर द सोलिंग. सोलिंग पण इथं करून टाकायचं
ओके.
आणि पीसीसी करायचं आणि मग करायचं, मग नाही प्रॉब्लेम येत, मग इट विल नॉट सेटल.
पण त्याचं डिझाईन म्हणजे फॉर टॉप लोड ओनली, नॉट बॉटम लोड.
बॉटम लोडचा संबंधच नाही आपलं, ह्याचं कसं लोड
नाही
आपण
ना.
डिझाईन करतो. हा
वॉटर टेबल नाहीच आहे तर
हा 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 राईट राईट.
अँड इफ देअर
इट
इज
इज डायरेक्टली रेस्टिंग ना, रेस्टच होतंय ना ती.
हा
कसं आहे इथं युडीएल आहे बरोबर का आपल्याला, समजा आपण 3 किलोन्यूटन पर स्क्वेअर मीटर पकडतो मी लाईव्ह लोड से कारचा वगैरे, ह्याचा किती येईल 200 mm चा 5 येईल, 5 किलोन्यूटन पर मीटर स्क्वेअर डेड लोड.
येस हो डेड
प्लस हे 3, हे किती झालं 3 5 8, अजून समजा एसआयडीएल धरला 10 धरू चला, 10 किलोन्यूटन पर स्क्वेअर मीटर इज द डाउनवर्ड लोड. अँड व्हॉट इज द कॅपॅसिटी ऑफ सॉइल? 600 किलोन्यूटन पर स्क्वेअर मीटर. म्हणजे काय होणार याला, काहीच होत नाही बरोबर ना.
जास्त आहे.
Capacity is quite high regarding SBC we can say. त्यामुळे याचा काहीच नाही विषय. There is no need to design this. ते ऑटोमॅटिक होऊन जाईल.
ओके. आणि
इफ इट इज अ सस्पेंडेड, अल्टरनेट काय
3.5 मीटरला माझा सपोज वॉटर टेबल इज ॲट ग्राउंड लेवल.
इथे
I will have to design this raft slab for 3.5 meter pressure, water pressure
Yes.
from below, no?
Yes, like this.
बराबर ना सर?
Yes, in this case, this will be your fixity point. Okay, analysis साठी. आणि हा असा राफ्ट होईल.
Yes.
हा मॉडेल करायचा, उलट स्टील टाकायचं. मग देन यू नीड टू मॉडेल दिस assuming here support. म्हणजे मॉडेल करताना मग कसं होईल ते, दिस विल बी इथं आपला हे होईल सपोर्ट, आणि हा
अपवर्ड प्रेशर.
आणि हे आपण स्लॅब मॉडेल करायचा. वी कॅन डू इन स्टॅट प्रो ऑर सेफ. आणि त्याच्यामध्ये मग फ्लॅट स्लॅब मॉडेल करायचा. सो इट इज अ फ्लॅट स्लॅब सिस्टीम. फ्लॅट स्लॅब कसा मॉडेल करतो आपण, फ्लॅट स्लॅब करायचा. मग ते फ्लॅट स्लॅब करायचं आणि मध्ये सपोर्ट द्यायचे त्याला कॉलमच्या लोकेशनला. लेट्स से दिस इज युअर, आय एम युझिंग मिक्स लँग्वेज बिकॉज अदर पीपल विल ऑल्सो गेट दॅट वे.
If we have beam to beam connection also at that level, then can we design it one way or two way?
Yes, definitely. If you are providing beam, say let me draw this. Let's say we are having columns like this. Here we are having columns. So there are two ways of either you can do the flat slab. In that flat slab, you know that we have a column capital. So this will be your column capital here. This is your column capital.
Yes.
Which should look like something. ऐसा कुछ तो रहेगा.
Yes, right.
This is your column capital. And
flat slab analogy.
Flat slab analogy, exactly. Only the pressure is upward, so you will have a more say top steel here in this zone, then here in this zone top steel, in this zone top steel, and depending on the bending moments, you know how it is for vertical downward. Yes. It is a vertically upward. That's it. Reverse case. So this is one case.
3.5 मीटरचा माझा वॉटर प्रेशर आला. सपोज जो राफ्टचा टॉप आहे त्याच्यावर मी 1 मीटरचा मुरुम फिलिंग केला पुन्हा. सपोज
इथे
सपोज त्याच्यावर 1 मीटर, 1 मीटर इंटू सपोज 2 means 20 is my that soil pressure from above. So will that be nullified for bottom pressure then?
Yes, definitely. You can nullify. Let's say
that
you can nullify by adding the weight, dead weight.
Suppose 1500 kg per meter cube is my soil density. So and 3500 is upward pressure.
Right.
So I can design for 2000. Then upward pressure.
So that method is used for controlling the uplift stability actually. So that is the way we do that. वरून लोड द्यायचा, मास टाकायचा additional. So you can have plumb concrete or filling also, murum filling. In that case only, but see this raft level is important because then you will have raft here, isn't it?
At bottom.
Karan maybe it is a functional level, na? Because you cannot disturb this level.
That is parking level.
You can do this way also, or you can design this for 3.5 meter, say, because
water.
This is a hard level, right? Hard strata. Footing is
Yeah,
embedded
right.
here. So only slab will deflect.
Oh,
Whatever you are saying is generally applicable for water tanks, because water tank may float. Because there is no footing like this, which is embedded in the rock sometimes. If it
only
is this
rough, yeah.
footing is in the rock, then this will anchor. So it will have a fixed support. Such kind of fixed support will be there. And this column will not go above, because say if it is a building, see there is a building above. That means definitely building cannot lift, right? Only this
Right.
slab will lift. Then it is better to design for 3.5 meter uplift pressure instead of having such, we can say, murum filling or this double work. Okay, it will have a little thicker slab and more steel, but fine. This will have again, then level of the raft will be here. Then this will be soft, compact, soft soil here. And then I would not go for this as a choice. Unless and
Sir,
until
in
there is a really issue of the uplift pressure. If this is giving so much of high heavy steel and concrete, then okay. Then your choice may be good at that moment.
Sir, in PV structure, many columns are uplifted in PV structure. If column are means at longer spans.
Right.
In that case, means
Yes, your
the
choice is good.
weight of soil on footing. Can we consider that weight of soil on footing and
Yes.
self weight of footing for the uplift?
Yes. See, uplift calculation generally, how it is, how we can take. So let's say. Let's say this is your footing.
In PAB structure, above plinth it is steel and below it is RCC.
See,
foundation board.
who is helping for uplift? I will tell you. This is the soil mass, not only vertical, even diagonal. I am saying.
Okay.
So this much of soil you can take for uplift.
Okay, we can consider now that.
Even this, yes, yeah, depending on your angle of repose. Yes, this you can take for uplift calculations. This is your downward weight, and let's say there is a plus self weight of footing, and this is your upward. So sum this and check whether it is okay or not. This also you can take. Please. I think this criteria is given in American code, ACI code. You'll find this. But say you just draw this angle of repose as given in the Geotech report, and then you can take. Or you can, as a conservative approach, you will think of this first. ऐसे समझेंगे कि ये करेंगे सिर्फ पहले simple. And if it happens that इसमें pass नहीं हो रहा, then use this because this additional is always there.
Because they give uplift load on that their connection level.
Correct.
That is at nut bolt.
Yeah. Base plate level. Yes, base plate level. The base plate है ये pedestal and then there are anchor bolts here. Yes.
एक 40 मीटरचा स्पॅन होता. 40 मीन्स तर त्याच्यामध्ये तो खूप हेवी त्याचा अपलिफ्ट यायचा.
करेक्ट.
अपलिफ्टर. त्या केस मध्ये आम्ही असं केलं होतं एक 15 वर्षापूर्वी. पण ते बरोबर आहे की नाही माहिती नाही, पण आम्ही आमचं असं
येतं ना घेता नाही
फंडामेंटल.
नाही बरोबर आहे ना, कॉमन सेन्स आहे ना हा ऍक्च्युअली. कारण शेवटी हा अपलिफ्ट होताना हे फुटिंग वर येईल आणि सॉइल पण आहे ना तिथे. डेफिनेटली हे होईल. इव्हन हे पण पॅरामीटर पिक्चर मध्ये सॉइल कधी फेल अशी होत नाही वर्टिकली. ती अशी तिरकी जाते. ह्याला कोन म्हणतात, कोन असतो ना. इव्हन यू माइट हॅव सीन बेस प्लेटचं कोन. समजा दिस इज युअर बेस प्लेट. आय विल टेल यू से फिलॉसॉफी इज सेम इन स्ट्रक्चर इंजिनिअरिंग एनीवेअर. समजा ही बेस प्लेट आहे and this is your anchor bolt, let's say. Okay. And then you are having let's say pedestal like this. Okay.
Yes.
And below the pedestal we are having, let's say, footing. Now when there is an uplift to this anchor bolt, there will be cone formation like this. Okay, so this will be your failure plane. Okay, this is your failure plane. Generally, whenever we decide the anchor bolt design, we make sure that it is not crossing. Okay, it should not cross.
फुटिंगला पण सेम आहे ना सर?
फुटिंग
ओव्हरलॅप झाल्यावर ते क्रॉस नाही झालं.
येस. आता समजा माझं एक साइडला एक फुटिंग आहे समजा, तर this is your failure plane. So then your footing should not come here like this. Okay. Let's say we are having footing levels different. Sometimes it may happen. Then this failure plane should not cross through this. Otherwise, whatever load is here, part load will go on this footing.
That is
Then
why
you
we
need
take horizontal and vertical distance same. That.
so in this case, let's say this is your failure plane, then I will provide footing at this location. Okay. So this is we generally do. And if it is not possible, then you add the load, the footing. Sometimes functionally it may not be possible for you. Then you can think of like this, or if it is coming like this, then you can think like this also. Create some wall and then add this load reaction you calculate and add this in the footing. So it's we can have different options. Yeah.
चांगला झाला सर सेशन एकदम.
Yeah.
मजा आली.
ऍक्च्युअली कसं प्रॅक्टिकल शिकल्यावर एक मजा येते, वेगळीच येते. कारण there are many things which we don't learn in books or some trainings, but such kind of problem solving is a really good discussion. I will be sharing with all of you in YouTube also, on our YouTube channel. Please subscribe. So I'm going to come with such kind of solutions on the YouTube, because all solutions cannot be possible in one training program. But I know that such kind of questions people are getting in their projects. So definitely we can have a discussion. See, the answer may not be the same, because as a solution provider, we can have multiple solutions. But at least thought process gets developed through that process.
सर आता एक अजून डिझाइन आम्ही केलं होतं की देयर वेअर 3 बेसमेंट्स. मीन्स 3 फ्लोर बेसमेंट्स.
3 फ्लोर बेसमेंट. ओके.
हा, आता तुम्ही जसं म्हटले की टॉप टू बॉटम हाईट जी आहे, म्हणजे पडदीचा टॉप ते फाउंडेशन बॉटम, राफ बॉटम, तर तो ट्रायंगल आपला येतो गामा एच, बरोबर. तर त्याच्यासाठी आपण आता सपोज मी एक फ्लोअरचा डिझाईन केला खालच्या बॉटमचा, आणि त्याच्यावरचा पण डिझाईन करायचं आहे, तर जे हॉरिझॉन्टल माझे डायफ्राम्स येतात स्लॅब. सो कॅन आय कन्सिडर इज ॲट कंटिन्युअस रिटेनिंग वॉल फॉर सच कंटिन्युअस स्लॅब जसा असतो,
रिटेनिंग वॉलचे सपोर्ट्स ना घेऊ शकतो ना, डेफिनेटली. येस.
माझे हॉरिझॉन्टल सपोर्ट जे आहे 3 फ्लोअरचे मधले, ते पकडले आणि जो ट्रायंगल लोड आहे असा आपण कन्सिडर करू शकतो ना डिझाईन त्याची.
See, how can we do? See, there is a slab over here, you are saying, right? Slab or beams are there, correct? बरोबर ना?
slab. Yes.
And then there is a retaining wall here, having
vertical.
This is your retaining wall. This one is sorry.
तर ते प्रॉप कॅन्टिलिव्हर सारखे आपण
Propped, yes, definitely.
कंटिन्युअस डिझाईन.
Yes, surely.
हा क्वेश्चन मी साने सरांच्या ऑफिसला आमचं एक डिझाईन होतं, त्यांना विचारला होता, तर ते म्हणे असं घेऊ शकत नाही.
नाही घेऊ शकतो ना, काय प्रॉब्लेम आहे.
आणि मी केलेली आहे अशी.
नाही करायलाच पाहिजे. सी, समोर आहे ना, फक्त एक आहे, ह्याच्यात काय करायचं. हा जो बीम आहे किंवा स्लॅब आहे, स्लॅब एस्पेशली स्लॅब, आय एम सेइंग the steel should go inside the wall.
That's a detailing. Yes.
Detailing is very important because you are assuming prop, so reaction has to be transferred in this slab. आता याच्यामध्ये इकडे इकॉनॉमी तर परफेक्टली बरोबर घ्यायलाच पाहिजे ते, आणि इकडे वॉल पाहिजे. डोंट फॉरगेट दिस, अदरवाइज हे पुढे रिस्प्लेस नको व्हायला. गेटिंग?
नाही, ते तर प्रॉपर त्याचं,
कारण इकडून हे आहे, म्हणजे ह्याच्यात कॉम्प्रेशन येईल, या स्लॅब मध्ये ह्याच्यामध्ये कॉम्प्रेशन येईल. Then this beam slab actually mainly, कारण रिटेनिंग वॉल ही रनिंग आहे ना फुल.
येस.
हा स्लॅब महत्वाचा आहे. बीम ठीक आहे, दॅट विल हॅव स्मॉलर प्रॉप्स, पण स्लॅब इज अ ऍक्च्युअल प्रॉप फॉर रिटेनिंग वॉल्स. This is throughout.
Yes.
And then definitely this will have bending moment, something like. आता हे जर असं प्रेशर आहे आपल्याला समजा, तर कसं होईल, असेल ना मोमेंट इकडे
बॉटमला फिक्सिटी राहील,
आणि हे असं कंटिन्युटी येणार, असं कंटिन्युटी येणार, असं कंटिन्युटी येणार. आणि जर इथं एंड झालं तर इथं 0 किंवा फिक्स पण धरू शकता, डिपेंड्स ऑन यू. फिक्सिटी असेल तर इथं स्टील टाकायला लागेल, फक्त बघायला लागेल. अँड द मोमेंट ऍट दिस झोन विल बी लेस बिकॉज द प्रेशर इज लेस हियर, ट्रायंग्युलर. As you go down, then this will have more values. And you can
झाल्यावर हे कंप्लीट झाल्यावरचं सिच्युएशन असतं.
करेक्ट कंप्लीट झाल्यानंतर.
आणि बॅक फिलिंग विल बी डन आफ्टर कम्प्लिटिंग ऑल द फ्लोर्स.
करेक्ट.
असं जाईल ना याच्यात.
तसंही करता येईल. आणि इफ यू फील हे आहे, काय म्हणतात त्याला, फिलिंग
filling.
स्लोली होतंय पार्टली, देन कन्स्ट्रक्शन सिक्वेन्स प्रमाणे पण अनालाइज करता येईल की बाबा एवढंच फिलिंग झालं,
खालचा
ही
part
मोमेंट,
cantilever.
तर ही मोमेंट डायग्राम काढायची, नंतर वरचं भरल्यानंतर फुल मोमेंट डायग्राम, अँड इफ द
Yes.
मॅक्सिमम ज्या मोमेंट आले त्याला डिझाईन करून टाकायचं.
ते आपण असं करू शकतो ना,
शुअरली 100%. अरे
कारण
मी
ते
म्हणतोय
सानेचे जे इंजिनियर होते ना, तर ते ऐकायलाच तयार नव्हते आणि त्यांनी अराउंड 600 थिकनेसचा वॉल दिला होता याला.
नाही हे चुकीचं आहे.
खाली.
दिस इज व्हेरी रॉंग.
खूप हेवी होता, खूप
नाही
हेवी.
हेवी, कारण कसं आहे माहितीये का, इंजिनिअरिंग नॉलेजचा योग्य वापर करायला पाहिजे ना, रिसोर्स कॉस्टिंग कशाला वाढवायचं ना.
आणि आम्ही सेम डिझाईन केलं नाशिकमध्येच, असंच सेम स्ट्रक्चर केलं, तर त्याच्यामध्ये खाली 300चा होता आणि त्याच्यावर 230चा होता.
करेक्ट.
म्हणजे खूप डिफरन्स होता.
नाही होतं ना, मी पाहिलेले आहेत. यू विल बी सरप्राईज. ही जी कन्सेप्ट मी सांगतो, मी आय हॅव डन ONGC प्रोजेक्ट केलं होतं एक, नॉट ONGC, आपलं इस्रो आहे ना, इस्रो तिरुअनंतपुरम. तर त्याच्या प्रोजेक्टमध्ये मी होतो ना, त्यावेळेला त्यांच्या राफ्ट ही किती आली होती माहितीये का, 1200 mm.
अरे बाप, हाईट
हाईट होती जास्त, पण या कन्सेप्टच वापरले नव्हते. मी नाव डिस्क्लोज करत नाही कन्सल्टंटचं, पण हे असं केलेलं होतं.
अर्धी झाली असेल.
हे 600 ला आलं.
आणि स्टील चेंज झालं असेल.
32चे बार होते त्याच्यामध्ये.
ते 20 mm ला आले असते.
20 आलं, 20 mm 16-20च्या रेंज मध्ये बसले ते. काय झालं त्या प्रोजेक्ट मध्ये मी जे होतो ना, तर त्यांच्यामुळे 15 करोडचा लॉस होणार होता कंपनीला आमच्या. समजलं? म्हणून काय केलं, आम्हाला हे केलं, इन्व्हेस्टिगेशनला पाठवलं की ते स्क्रुटिनी करा. कन्सल्टंट दुसरा होता, आम्ही फक्त हे होतो रिव्ह्यूअर आणि कोऑर्डिनेटर्स. ऍक्च्युअली ते सगळं डिझाईन ड्रॉइंग तेच करत होते. मग हे एवढा मोठा विषय झाल्यानंतर मोठा प्रॉब्लेम झाला ना, की कुठं आहे गडबड. मग तिथं गेल्यानंतर मुळात त्यांनी काय केलं, रिटेनिंग वॉलचं हाईट आहे ना, कंटूर लेवल डिसाईड हे नाही केल्या, चेक नाही केल्या, आणि त्याच्यामुळे हाईट कशा पण यायला लागल्या. आता कसं, ठीक आहे, इट वॉज अ मिस्टेक बाय देम. मग त्याच्यात मध्ये मग आम्ही हे सगळे प्रॉपिंगचे सजेशन दिले सगळे, की जिथं प्रॉप आहे तो डेफिनेटली
at all levels is necessary.
At all level is necessary, and see, it was a big mistake. 15 crore is not a joke. एवढा डिफरन्स प्रोजेक्ट मध्ये येणं. And we were a design build contractor, so we used to do the design in house and contractor, but design coordination होतं. And see, we एवढ्या सगळ्यामध्ये आमच्या सगळ्या व्हॅल्यू इंजिनिअरिंग सजेशन मध्ये 10 करोडचं आम्ही करून दिलं. 5 करोड झालं, पण ते मॅनेज इट सम, आय डोंट नो. बट 10 करोड पर्यंत स्ट्रक्चरल कॉस्ट मध्ये त्यांनी हे केलं. नंतर ते फंक्शनल आणि आर्किटेक्चरल आणि काय मेकॅनिकल मध्ये त्यांनी केलं ते कॉस्टिंग मॅनेज. बट दिस वॉज द, आता 600 आणि हे भरपूर होतं रेटिंग.
आम्ही एका ठिकाणी असंच केलंय की आता तुमचा जो ट्रायंग्युलर पार्ट आहे ना, आम्ही जसा आपला सॉइल कोलॅप्स होतो तर त्याला रिव्हर्स आम्ही दिला होता. म्हणजे एक साइडला रिव्हर होती, रिव्हरचा तो हे होता एंडचा वॉल असतो ना, काय म्हणतात,
राईट.
तर तो होता, आणि त्याच्या मागे ते वाहून नाही जावं म्हणून आम्ही त्याला उलटी रिटेनिंग वॉल केली आणि त्याच्यात पूर्ण दगड फिलिंग केली.
करता
म्हणजे
येतं
ती रेजिस्टिंग मुवमेंट केली आम्ही. ती ओव्हर टर्निंग मुवमेंट येत होती ना पाण्यामुळे, तिला हे करण्यासाठी आम्ही रेजिस्टिंग करण्यासाठी पूर्ण दगड फिल केले आणि
येतं ना. इव्हन ह्या केस मध्ये पण आहे ना,
आणि वरून परत त्याला स्लॅब टाकतात वरून पण.
हे आहे ना, या झोन मध्ये आहे ना, बऱ्याच वेळा रबल टाकता येतं, कारण हे सॉइलचं फेल्युअर प्लेन आहे ना, हाच ब्रेक करायचा. आता इथं जर स्टोन टाकले ना मी, रबल से हिअर, then the load goes directly down, because हे जे फेल्युअर सॉइल मध्ये असतं, हे रॉक मध्ये नसतं.
सर ती सी व्हॅल्यू 0 पकडली तर हे करावंच लागतं ना,
राईट.
मारून त्याला.
इव्हन ब्रिजेस मध्ये तर इथं लेअर मध्ये करतात, माहिती आहे ना, इथं ते जिओ टेक्सटाईल टाकतात अशा लेयर्स मध्ये. त्याच्यामुळे हा जो फेल्युअर प्लेन आहे ना, हा ब्रेक होतो आणि लॅटरल सॉइल प्रेशर होतच नाही क्रिएट. इट गोज डायरेक्टली डाऊन लाईक दिस. So there are such kind of retaining walls generally used in bridges. So no, this failure plane is cut. Okay.
हा टेक्निक्स आहे पण आपले लोक यूज नाही करत.
नाही, हे दिस इज द रिअल इंजिनिअरिंग, स्ट्रक्चर इंजिनिअरिंग, दिस इज द रिअल इंजिनिअरिंग.
सेफर गेम करतात.
सेफर गेम नी मजा येत नाही. म्हणजे सेफर गेम काय, समटाइम्स यू मे सर्व्हाइव्ह, बट समटाइम्स क्लायंटला कळालं की यांची कॉम्पिटन्सी कमी आहे, तर यू विल बी इन ट्रबल. असं पण होतं ना.
सर मी तुमचा याचा कोर्स केला होता मागे, 1-2 वर्षापूर्वी होता ना.
हा, हा.
कुठलंय आपलं सॉफ्टवेअर वेगळं अजून स्टॅड नाही दुसरा.
सेफ इटॅप.
हा त्याचं केलं होतं. तर ते मला मेसेज आला, मी जस्ट म्हटलं आज चला वेळ आहे थोडा, तुमचं लेक्चर आहे ऐकू आणि काय डिफिकल्टीज विचार.
नाही आहेत माझे थोडे अपकमिंग सेशन आहे, थोडे वेगळेच सेशन्स आपल्या ट्रेनिंग मधून झाल्यापैकी अजून ऍड केलेत मी. सो दॅट्स वाय आपले जे जुने स्टुडंट आहेत त्यांना परत हे केले की जॉईन दिस. कारण
आम्हाला
कसं
अजून
आहे,
नवीन शिकायचं आहे.
हा कारण कसं इट्स अ
आहे.
कंटिन्युअस प्रोसेस.
रिटायरमेंटला आहे पण तरी अजून आम्हाला शिकायचं आहे.
नाही इट्स अ कंटिन्युअस प्रोसेस
अराउंड.
ऍक्च्युली.
चालेल ना सर, चालेल. आम्हाला
Okay.
शेअर कराल सर प्लीज.
येस सगळे सेशन आहेत
ते
ना
mail-
पुढचे माझे, ते सगळे
mail
तुम्हाला
ID
येणार आहेत.
मेल आयडी वर आता आमचा आहे का नाही माहित नाही, मी शेअर केला होता.
क्लासरूमला आहेत का तुम्ही?
नाही ह्या व्हॉट्सअप ग्रुपला आहे मी आपल्या.
नाही वी विल ऍड यू इन द क्लासरूम. क्लासरूम मध्ये
आता
सगळे
मी-
व्हिडिओ असतील, मी घेईन ते सगळे असतील तिथे.
चालेल ना सर, प्लीज सर,
येस
प्लीज. चॅटिंग मध्ये मी मेल आयडी केलं शेअर.
हो ओके.
थँक्यू सर.
थँक्यू संदीप. क्वेश्चन है क्या
थँक्यू
कुछ?
सर. गुड नाईट.
गुड नाइट.
नाही.
थँक्यू.
Yes.